For today's video, we will answer a math challenge given by one of our followers. And the question goes like this. Determine the fifth term of 1 plus 2x raised to the power of 1 over 2. Now, you can pause this video if you want to give this problem a try. And now, let's answer this question together. Alright, so this is not usual. So determine the fifth term of the expansion of 1 plus 2x raised to the power of 1 over 2. So this is not usual because we always see an integer exponent or a positive exponent. But this time, it is a fractional exponent. And our goal is to find the fifth term of the expansion of 1 plus 2x raised to the power of 1 over 2. Now, how we do that? So to answer this question, we will use some theorem, of course. So let's have the generalized binomial theorem. So the expansion of a plus bx raised to the power of n, or simply equal to a raised to n multiplied by 1 plus b over a times x raised to the power of n. This can be written as a raised to n multiplied by 1 plus n times b over a times x plus n times n minus 1 over 2 factorial. This is factorial. Multiplied by b over a times x raised to the power of 2, and so on and so forth. So where n is not positive integer, it is an infinite series valid when the absolute value of x must be less than the absolute value of a over b. Now, this is the generalized binomial theorem, but our given, this a is just 1. So, let's use the generalized binomial theorem when a must be equal to 1. And here it is. So, the expansion of 1 plus bx raised to the power of n must be equal. So, this is, in this case, a must be equal to 1. Okay? So, it must be equal to 1 plus n times bx plus n times n minus 1 over 2 factorial. This is 2 factorial times bx raised to the power of 2 plus n times n minus 1 times n minus 2 all over 3 factorial. This is 3 factorial. 3 factorial times bx raised to the power of 3, and so on and so forth. It is an infinite series where n is not a positive integer. So it is valid when the absolute value of x must be less than 1 over the absolute value of b. Now, we will use this generalized binomial theorem when a equals 1 case to answer this question. So our goal is to find the fifth term of this expansion. Alright. Now, given this expression 1 plus 2x raised to the power of 1 over 2, we can say that the value of b must be equal to 2. Alright, so based on this pattern, and n must be equal to 1 over 2, which is the exponent of this expression. Alright, now we can now find the first term up to what term that we want. So let's have the first term. Of course, the first term is 1. Very simple. Now, let's have the second term. So the second term must be equal to just n multiplied by bx. So we have n equals 1/2, and this b must be equal to 2. So we have 1/2 multiplied by 2x. Now let's simplify. We know this is over 1, so we can cancel out 2. So this is simply equal to x. So we have equal 1 plus x. Now let's have the third term. The third term must be equal to just n multiplied by n minus 1. So we have 1/2 times 1/2 minus 1 over 2 factorial multiplied by bx, so 2x raised to the power of 2. Now let's simplify this. 1/2 minus 1, this will give us negative 1/2. 1/2 times negative 1/2, this will give us negative 1/4. Now this 2 factorial, this is just 2 times 1, or simply equal to 2. Now, negative 1 over 4 divided by 2, this will give us negative 1 over 8. Now, 2x raised to the power of 2, this will give us 4x squared. Now, we have denominator of 4. So, negative 1 over 8 multiplied by 4 over 1. This will give us negative 1 over 2 times x squared. So, this is the third term of this expansion. And it keeps going up to infinity. Alright? Now, let's have the fourth term. So, the fourth term must be equal to n multiplied by n minus 1 multiplied by n minus 2 over 3 factorial multiplied by bx raised to the power of 3. So we have 1 half times 1 half minus 1 times 1 half minus 2 over 3 factorial multiplied by 2x raised to the power of 3. So now let's simplify. 1 half minus 1, this will give us negative 1 half. 1 half minus 2, this will give us negative 3 over 2. Now if we multiply this, 1 half times negative 1 half times negative 3 over 2, this simplifies to negative 3 over 8. Now, this 3 factorial, this is 3 times 2 times 1, or simply equal to 6. Now, 3 over 8 over 6, this simplifies to 1 over 16. Now, 2x raised to the power of 3, this will give us 8x raised to the power of 3. And we know we have over 1 here. So 1 over 16 times 8 over 1. This simplifies to 1 over 2. Then multiply it by x cubed. So this is the fourth term of this expansion. So we have the first term, the second term, the third term, and the fourth term. But we want is the fifth term. So why not? Let's add the fifth term. So the fifth term must be equal to 1 half times 1 half minus 1 times 1 half minus 2 times 1 half minus 3 over 4 factorial, continuing the pattern, times 2x raised to the power of 4. Now let's simplify this. 1 half minus 1, this will give us negative 1 half. 1 over 2 minus 2, this will give us negative 3 over 2. 1 over 2 minus 3, this will give us negative 5 over 2. Now, multiplying this, 1 over 2 times negative 1 over 2 times negative 3 over 2 times negative 5 over 2, this will give us negative 15 over 16. Now, negative 15 over 16 over 4 factorial. 4 factorial, we know this is 24. So this simplifies to negative 15 over 16 times 1 over 24. We multiply this because if we simplify 2x raised to the power of 4, we have 16x raised to the fourth power. So take note, we can cancel out the 16 right over here. So this simplifies to negative 15 over 24x raised to the fourth power. Now this 15 is 5 times 3 and 24 is 8 times 3. So this can be simplified to negative 5 over 8x raised to the fourth power. And that is the fifth term that we want to find. So we have here the answer. But if you want to extend, you want to get the 6th term, the 7th term, the 8th term, and so on and so forth, you get 7 over 8x raised to the fifth power, the 6th term, negative 21 over 16 times x raised to 6, we have the 7th term, plus 33 over 16 times x raised to 7, we have the 8th term, and so on and so forth up to infinity. Therefore, our answer to this question, we want to find the fifth term of this expansion, 1 plus 2x raised to the power of 1 over 2, and our answer is negative 5 over 8 times x raised to the fourth power. And as always, we are done.